Okay, so if you are not in my class today, then you are not responsible for doing this part of the lesson, but I still want to show you guys just so that you guys have the same visual as if you were. So this is a piece of, a small piece of grid paper here, and it's already cut into a rectangle. Today's lesson, if you haven't guessed already by the title of this video, is on rectangles. We've been talking about quadrilaterals the past few weeks. We've been focusing a lot on the parallelogram. So today we're talking about a type of parallelogram, which is a rectangle. So we're going to go over some of the characteristics of a parallelogram and see if this guy right here matches those of a parallelogram to kind of confirm that it is indeed a parallelogram. Fold our rectangle in half, then I can very obviously tell that these guys are congruent, right? So that is our way to tell that they are congruent. So I'm going to actually mark it. It's going to be a little bit hard because I did actually cut part of it off. And so that's going to get rid of some of the signs. So I'm going to make a symbol that's kind of similar to that of our congruence. And then I'm going to do the same thing on this side over here. I'm just going to fold it again in half. And look at that. They match up on this side. And that confirms that this side is also congruent. Okay, so those were some qualifications that our parallelogram had to have, was that opposite sides here were congruent. Okay, another one was that they are parallel. Another one is that opposite angles are congruent. Okay, so for that one, I'm going to fold my paper into fourths. And in doing so, oh, look at that. They are all congruent. They all line up. They all match. And actually, for rectangle, the unique thing about that, and as compared to just a parallelogram, is that they are all 90-degree angles. So I'm going to go ahead and mark my 90-degree angles. That yes, they are indeed congruent. In fact, they are supplementary angles. The diagonals bisect. So right here where we have just already folded, that's going to indicate our center, the center of the rectangle. If these lines meet at that center, that is going to confirm for us that these lines in fact bisect. And over here, going from corner to corner. And yay, look at that, right at the center there. So that is where our center is. We can confirm that they bisect. So another unique thing about the rectangle is not only do they bisect, each one is congruent. Okay, so that means this diagonal is congruent with this diagonal. And when they bisect, each part is also congruent with each other. We are back over at our Doodle Notes page, and we're going to zoom in right on rectangles. So we're going to focus on the rectangle. We're going to decorate our doodle noting. Rectangle is a parallelogram. All right angles. So it's basically a really good way to say it's going to have all of the characteristics that a parallelogram does, except for the fact that all of its angles are going to be right angles. Let's do our symbols here so they are congruent. And this one's also congruent. And then opposites are also parallel. So here, these are parallel, and these are parallel. Okay, so check. We have marked off the congruency and parallel of all the opposite sides. And diagonals bisect each other. So this one is going to bisect this one. And that means this one is also going to bisect this one. And not typical of a parallelogram, this is a little bit more specific to a rectangle. These are also going to be congruent with each other. And that we already showed with the previous demonstration that I did with the grid paper. Diagonals bisect each other and are congruent. All right, going over to our book of quadrilaterals. This is our next step in kind of introing our the next quadrilateral. So just kind of bypassing all the pages we've already talked about. We talked about the quadrilateral family tree. I guess I forgot to do this page with one of my classes, but we'll eventually get there. But let's talk about this rectangle. So let's zoom in. Rectangles are, like we mentioned, types of parallelograms. So that means all of the characteristics of a parallelogram will also be found in a rectangle. So, for example, we have here opposite sides are congruent. Okay, so this side is congruent with this side, and this side is congruent with this side. Okay? Opposite sides are also parallel. So this guy is parallel to this one. this one parallel to that one. We also have opposite angles are congruent. So that is a typical characteristic of a parallelogram, that the angles would normally be congruent with each other. But a rectangle goes even further than that to not just say that they are congruent, but they are also right angles. So I'm going to indicate here, they are all right angles. Okay. Consecutive angles are supplementary, which is obvious by the 90 degrees, 90 degrees. That means together they're going to add up to 180, which is also going to be true going other directions as well. All right, diagonals bisect each other. So in that way, we showed that these are congruent. These are also congruent. And not just that, they are all congruent with each other. Here, so these characteristics right up to there, these are going to be consistent with that of a parallelogram. Okay, so you can stop this video right here and work on these problems on your own. I'm going to walk us through the first one so you kind of get a gist of what you're expected, but you're going to try the rest on your own. And then you are welcome to check with me or check with a friend to see how you did. So quadrilateral QRST is a rectangle with diagonals that intersect at P. If measure of angle RSU is equal to 3x minus 5, then measure of angle UST is 4x plus 4. Find the value of x. Okay, so for this one, like I mentioned before, that anytime you are not given a picture and you're only given letters, the way that you are supposed to label it, you start anywhere, and then you are going to go in a clockwise direction. Quad RSTU, I guess I'm going to start here. I don't think it really matters since all of these are equivalent anyways, or they're all congruent, these angles. Okay, so they have diagonals that intersect at P. If measure of angle RSU here, okay, and UST right there, so UST, that this one right here is the 3x minus 5. This guy right here is the 4x plus 4. Okay, so we want to find the value of x. Well, having a nice diagram here shows us that that is referring to this corner over here, which we know is a right angle. So that means to solve this, we're simply going to add these guys up, and that should equal a right angle. And that's all it's asking for. In this case, it is asking for the value of x. You always got to make sure after you find whatever it is you're looking for that that is in fact the question that you're answering. All right, good luck. Enjoy the rest of it. So let's start with rectangles. So if you need a review of all the properties of things, it's all right here, but we've gone over them quite a few times, like I think literally 3 times, just the very basic properties. So hopefully by now you are very familiar with them. But let's do this problem here. It is telling us to use the properties of rectangle to find the length of line ET to the nearest tenth. Okay, so it gives us some clues here. They said that what is this? Rectangle RECT is a rectangle. So know about a rectangle to help us find our answer. RA, let me zoom in on this, is 43x. And AC is 214x minus 742. Wow, look at that nice small number. Okay, in this case, we know that one of the properties of a rectangle, I think it's mentioned over here, is that these are congruent, right? Diagonals bisect each other. So that means this here is going to be the same distance as here, which is also the same distance as here, which is the same distance as here. Okay. So we can set those equal to each other. 43x is equal to 410x minus 742. Okay. we're just going to do our algebra. And this is it rounded to the nearest 10. So this should actually be more of a like this kind of symbol here. Okay? We didn't finish the question. Remember, they're asking us what is the distance of, no, not that one, of this guy. So they're not interested in what x is. They want to know what the distance from ET. So now that we've found out what x is, and we also know that this distance ET is going to be the same distance as RC. So in that case, if we are able to plug in x into here and add them together, that will give us the distance of ET. Okay, so just to write this in an equation form, you can make this as simple as you would like. Okay, so this one is a little bit, I don't know, on the fun side, I'd say, because it is asking you to use a system of equations. So we did this before with our parallelogram. We're asked you to use a system of equation. And I think at this level, you guys should be able to do it. But for those of you who, haven't done it in a while, I will help you set it up in case you don't remember. But it's telling you to set up the system of equations to find the values of the variables. So I know that this, based on the properties of a rectangle, these are congruent and these are congruent. So I'm going to set those equal to each other. So we have here 3x minus 10 is equal to 2y. And x equals 4y. And then just like we did before, this one looks like a great example of substituting. So instead of this guy, we're going to plug this in for that. Okay? So now you are going to use that information. That is going to help you find what x and y are. You want to find the actual distance of the base and the height, because that is what B is asking you. And then finally, you're going to find the area. So hopefully you guys remember the area of a rectangle.